All right, today we're going to talk briefly about how we calculate the rate of change for a given set of intervals. So the function that we're given is the absolute value of x plus 2. And we're asked for three different rates of change. One is over the interval from -2 to 0, and then the interval from 0 to 3, and then the interval from -2 to 3. So you see, first of all, I have my function graphed. Just have this here for you guys to see. So first thing I'm going to do, I can do this without a graphing calculator, but it's a little quicker with a graphing calculator. So I graph the function. First thing I'm going to notice is it looks like this. So what we're asked to find in this is the intervals over a given period of time. So there are three intervals. We'll highlight these and then I'll probably remove this. One interval is from -2 to 0. So really the only portion of line that we are looking for is from here to here. So I'll highlight that in a yellow color. So when they ask me from -2 to 0, what they're asking me for is what is the, and we'll stay away from the word slope a lot of times because slope refers to a consistent rate of change. And we don't always have a consistent rate of change. In this case, we do because it is just a straight line. There's no break in it or anything of that nature. So the first interval is from -2 to 0. This is our yellow line here. If you happen to have a graph, you could just do the rise over run count, and that would work. The second set of intervals is from 0, do this one in red, to, which is here, to 3, which if I trace this up, that is here on the graph. So they're asking me for the intervals from 0 to 3. Again, this is another straight line, so this rate of change is also a slope. You can count your rise over run, that would work, that would be perfectly fine. Now the last interval that we're asked to look at is right here, from -2, which is here, to the value 3. So when we do this, we don't follow the line like you would think. What we do is we draw a straight line from our 2 points, and then we calculate the rate of change from one point to the next. So this is really 3 questions wrapped in one. So we will take these bit by bit. So I'm going to do a little bit of a review of some other things as well. So we will remove this and we will go straight to the table. Again, rise over run is always an option if you do have these values. So here we look at our table. Maximize this a little bit. And what we're going to do is calculate our rate of change. Now, our rate of change is the slope formula. If you need to write this down, if you don't have this saved to your memory, what we're going to do is take y2 minus y1 and divide it by x2 minus x1. Make sure that your x values are in the denominator. That's usually the most common mistake I see when I see students make these mistakes. So here's what I'm going to do right off the bat, since I have my calculator here, is I'm going to find these values that you're interested in, that they're interested in. So they said -2, so I'm going to write the ordered pair. -2 is at 4. The second value we're asked to see is 0, which has an output value of 2. Then it asks us for the value 3. We'll need the value 3. And then 3 comes out to 5. So I took my table and I extracted all of the x values and y value, the coordinates for each of those. And what I need to do now is find the slope or the rate of change for each of those. Remember, this is 3 questions, so we are going to answer all 3 questions. Now, I've seen this table. I'm going to remove the table because I've taken the important parts from the table, which is the ordered pairs. And I'm going to write them as ordered pairs, so I'm going to put these things in parentheses. Okay, so starting with the first one, we'll try to color coordinate this. What is the, and by the way, we were talking about this yesterday. What I essentially did when I looked up the value -2 is I took the function at -2. So when the function had a -2 as the x value, the output was 4. On the f of 0, the output was 2, and f of 3, the output was 5. So the examples you saw yesterday, that is what the f of means. What you're essentially doing is you're taking your equation. So if I say f of -2, I'm taking my equation, which is originally x, absolute value of x plus 2. But instead of using the value, the unknown value x, I'm using the known value of -2. So this is why we end up with an output value of 4. But if you graph these things and use table, you see how quickly I got the answers by reading off the table as opposed to working these out by hand. But that's what it's essentially telling you when we say f of -2. It means the function that we are interested in, and this one wasn't labeled f of x, it was labeled y, but it would need to be labeled f of x. But we take the function, and in place of all of our variables, we replace them with the given value. All right, so let's get back to what we were talking about, which is finding the rate of change between these intervals. I'm going to try to keep these color coordinated. So my yellow, I'm working yellow, is the rate of change from -2 to 0. So what I need to do is find the ordered pairs for these. So that's -2 and 0. So what we have is -2 with an output value of 4 and 0 with an output value of 2. I'm going to call this x1, makes this y1, x2, and y2. So I'll go back to my formula. The formula says y2, which in this case we're using the number 2, minus y1, which is 4, divided by x2, which is 0, minus x1. Well, this is one we have to pay attention to because it is minus a negative, which of course becomes plus. So our rate of change ends up being -2 in the top, +2 at the bottom. So our rate of change for interval -2 to 0 is -1. And if it helps you to think of rate of change as slope, you go right ahead, but they essentially mean the same thing. Slope just means a consistent rate of change, is what we have on this particular one. So let's move to the next. I did this in red earlier, so we'll try to stick to red as well. It says from the interval 0. Well, 0 has an ordered pair of 0, 2. And then the second interval is 3, which has an output value of 5. So I'm going to call this x1, y1, x2, y2. So we go y2, 5, minus y1, which is 2. Of course, this comes out to be 3, over x2, 3, minus x1, which is 0. So this has a slope of 3 over 3, which is 1. So my rate of change for interval 0 to 3 is 1. And then lastly, we have the one I did in green, which was from -2 to 3. So -2 had the ordered pair 4, and 3 had the ordered pair 5. And we're going to use our formula for the last time. Y2, whoops, don't do that. X1, Y1, X2, Y2. Now, if you make the Larger x value, x2, you'll never have a negative denominator. If that kind of thing interests you, go ahead and pay attention to that. If it's no different to you, then don't worry about it. So here we go. Y2, 5, minus y1, 4. Well, 5 minus 4 is 1. And you remember, this is the one that cuts through the graph. These are not a straight line to these 2 points. And then lastly, x2 minus x1. Make sure you use parentheses. You'll hear that a lot from me this year. If you're not using a parentheses, you're setting yourself up for failure, especially when the parentheses involves a negative number. So we have 3 minus a negative 2, which is essentially plus. Remember, minus a negative is positive. So we end up with 5 minus 4, 1 over the denominator 5. So our rate of change is going to be 1 over 5. Now, if you did the graph like we did earlier, you would have noticed to go from our points, I'm just going to do a rough draft of what that graph looked like. The graph looked like this. It was a U-shaped V, just a V. And our point -2 was in this area. And our point 35 was in this area. So what this is saying is what it had was a slope of rise 1 and right 1, 2, 3, 4, 5. You could have done the rise over run when you had the graph, but a lot of times when you do these, if you have fractions, it's a lot harder. If you end up with values that just don't want to work, sometimes the rise over run will be a problem. If we use the slope formula, it will always work for us. So this is how we use rate of change.